The localized electron bonding model. We're going to be drawing what are called Lewis structures. And Lewis structures show the number of valence electrons and how they're arranged around an atom in a molecule. Now remember that valence electrons are the electrons in the outermost energy level. And we can determine the number of valence electrons based on what group or column an element is on the periodic table. So we have 6 Lewis structure rules. Our first rule deals with the elements in our first period, hydrogen and helium. They will always obey the duet rule, which means they'll have a stable electron configuration with 2 valence electrons. Our second rule deals with the second period on the periodic table. Carbon, nitrogen, oxygen, and fluorine, they will always obey the octet rule, meaning they have 8 valence electrons in a structure in order to be stable. In our second period, boron and beryllium are exceptions to the octet rule. They can be stable with less than 8 valence electrons. The second row or period on the periodic table can never exceed the octet rule. And that's because they only have s and p orbitals, 2 electrons in an s maximum, 6 electrons in a p maximum, so they can only accommodate 8 electrons. Our next rule deals with period 3 and below. They often satisfy the octet rule, meaning that they're stable with an electron configuration with 8 valence electrons, but they can also exceed that by using those empty d orbitals that we find in those elements. And our last rule is when writing Lewis structures for compounds, satisfy the octet first, then place electrons in elements that are period 3 and below.